Hello, folks. This is your very first video in Unit 7, which is on inference for proportions. So this first section, is talking about confidence intervals, and then we'll move into hypothesis tests. Fair warning, there's a lot of videos in this unit. This unit is very long, but if you can master the concepts here in this unit, the next 2 units will be a lot easier because it's basically just a repeat, but with means and other statistics rather than proportions. Okay, so we're going to go ahead and jump into it here. So this first video is just on the basics of confidence intervals, what they are and why we use them. And then a little bit later in the section, in another video, I'll get into how we actually do those types of problems. These are very common free response problems on the AP test. Very, very common. Okay, so I, as always, have the slides up on the left side of the screen. Your notes are on the right side of the screen, and I'm just gonna kind of follow along with myself here, and you can follow along with me as we go here. So what we need to talk about before we jump into any of this inference for proportion stuff is I want to briefly remind you what we did with this last unit. So in the last unit, we looked at sampling distributions of proportions and means. Okay, and we use those sampling distributions to figure out how close a particular sample value is to a true value. Okay, but then the question becomes, well, what if we don't actually know the true value? Okay, which frankly in the real world is going to happen more often than not, right? It's very difficult to know an exact parameter value, a true value, a population value. That data is very difficult to come by. So the question then becomes, well, if we don't know the true value, then we can't create a sampling distribution. So what do we do? Right? What do we do there? Right? So that's what this whole section and really what this whole unit is about. Okay? So essentially, to answer the question that I just asked is, if we don't know a population value, then we have to estimate it using a statistic, right? Or a sample value, okay? In this unit, we're going to call those point estimators, okay? So your definition of a point estimator is a statistic that provides an estimate of a population parameter. So that's like a sample mean or proportion. Okay. So those are your sample values that we looked at a lot in the last unit. Okay. And then a point estimate is just one value of that particular statistic. Right. So your point estimators are your X bars and your P hats. Right? Those are your point estimators. Okay, so again, just to kind of recap for you, sampling distributions tell us how close a point estimate, right, so a sample value, is likely to be to the true population value. Okay. Then we have one more kind of vocab term that we need to know here, which is margin of error, which you probably have heard before, but may not have an exact definition for. Okay, so our definition in statistics of a margin of error is it's a number that tells us how close we believe our guess, right, i.e. our sample value, or our point estimate, is to the true value. Okay, it's usually better if we can have a smaller margin of error, right? But sometimes that's not possible, right? We do the best we can to minimize our margin of error, but there's a balance you have to strike, right? If you make your margin of error too small, then you have to be really, really sure in your in your choice, right? Like in your sample value, right? But if you make your margin of error too wide, then people may be thinking, well, what's the point? Like if your margin of error is that wide, like how accurate can your sample value actually be? Okay. The way we calculate margin of error is we use the variability of the point estimate in repeated simple random samples of the same size. So that's like what we did in the last unit when I would have you run lots of simulations and we create a sampling distribution from that, right? So you're doing essentially the same thing here, right? Your margin of error is based on your range and your standard deviation in repeated simple random samples of the same size, okay? So those are just some basics for you, right? Some basic vocab, okay? Now let's get into the meat of this, which is confidence intervals, okay? So what is a confidence interval, okay? So like I said, if we don't know the truth, right, we don't know the true value, we have to create our best guess as to what that true value is. Okay. And our range of those guesses, right, our best guess is a confidence interval. Okay. So the full definition here of a confidence interval, this is what it does. Okay. It gives us a range of plausible values for the true population value. Okay, and that true population value is usually a proportion or a mean. Okay, in this unit, we're going to focus solely on proportions. All right, and then we'll get into means in the next unit. Okay, so essentially, when you're creating a confidence interval, you start with your point estimate. Okay. You start with your point estimate, okay, and then you add and subtract your margin of error. Okay, so essentially, and I'm just going to draw what one of these looks like on your notes page over here, but essentially they look like this, right? If you start with say a point estimate here of maybe like a p hat value, and then you have a certain margin of error, say it's like yay wide. Oh, I really tried to make that the same. I really tried to make that the same length on both sides here. Let's try that again. That's about the same length, right? So that right there is your margin of error. You've probably seen digital graphs with things like this, right? In Excel and in Google Sheets, you can run data. Like you may have seen this in a science class where you can run data and you can gather data and you can turn on and off the margin of error, right? Okay, so that's what a confidence interval is. Okay, this is like a visual depiction of what a confidence interval is. Okay, now in statistics, we have this other important thing called a confidence level. Okay, your confidence level tells us how confident we are. How many times can Miss E say confidence in this video alone, right? Okay, but it really is exactly what it sounds like. It tells us how confident we can be, how confident we are that the interval we chose actually contains the true value, right? Or the population value, the parameter, okay? Typically in statistics, we want your confidence level to be at least 90% or higher, okay? And I hope that intuitively that kind of makes sense, like why that is, right? If somebody came up to you and said, hey, I think you're gonna win the lottery. Like I think this ticket is the winning ticket for the lottery, but I'm only like 50% confident in it, right? You wouldn't necessarily take that person to heart, right? But if somebody came up to you with a lottery ticket and said, yo, like this ticket, I am 99% confident that this is the winner right here, okay? You would take that much more seriously, right? Because they're much more sure of their, in this case, lottery ticket, right? We want in our confidence interval to be at least 90% sure that that confidence interval captures the true value. Okay, it's not necessarily that our actual statistic, so it's not necessarily that the p hat value is the actual true value, but we're just saying that the true value is somewhere in this interval. And I can say I'm 90% confident, or the most common confidence level is 95%. Okay, in statistics, that's the most common confidence level. Okay. What you see at the bottom here, this thing that says, if we take lots of samples, okay, that is your like interpretation of what a confidence level is. Okay. So essentially your confidence level comes from if you took lots and lots and lots and lots of samples, okay, we would expect that C%, so let's say 95% of those intervals will capture the true population value. Okay. All right. So what you see on the left side of the screen now is just kind of a review of all of those things that I just talked about. You can also see it here in green on the right side of your screen, okay? But I want to show you what confidence intervals look like, okay? And we are going to do this part, the creating confidence intervals, in class, so you can do this part in class with us, or if you miss that, you can do it later. But it's basically just kind of playing around with the idea of creating confidence intervals, okay? So what you see on your screen right now is I have a population, okay? Here's a normally distributed population that has a population mean, right? So this, my lovely dashed line here, is my true value. Okay, remember, this class is, if nothing else, a search for the truth, right? We are trying to find true values, okay? So what you see on the screen right now is 20 different confidence intervals, okay, that I ran, okay? And I ran 95% confidence intervals here, okay? So you can see the first 10 of them capture the true population mean, right? That population mean is somewhere within that interval, right? Again, not necessarily the actual statistic value, right? So that little bullseye looking thing in the middle is your point estimate, which, because this is means, would be X bar, right? So it's not necessarily that the statistic itself has to be equal to the true value. It's just that we've captured the true value somewhere in the interval, okay? You'll notice that some of these intervals are wider than others, okay? And I'm going to talk about why that is in a second, okay? But another thing I'm hoping you'll notice is this confidence interval right here does not capture the true value, okay? But I ran 20 confidence intervals, and 19 of them, 19 out of the 20 did capture the true value, which is about 95% of my intervals, right? So when we talk about confidence intervals, it's not that, oh, it'll be like there's a 95% chance that your interval captures the true value. That's not what it is. It's saying if we run lots of confidence intervals and create lots and lots and lots of confidence intervals, then we would say about 95% of them will capture that true value. Okay. All right. So the last thing I want to talk about in this little part before I go into your interpretations is the width of your confidence intervals. So like I said, you probably noticed that there's some intervals that are much wider than others, right? There's some that are not very wide at all, right? Say like this guy, right? And then there's others that are very wide, like this guy, okay? So the general rule is that the higher your confidence, the wider your interval has to be, okay? So like I said, we are going to do this part in class, but a higher confidence level means you need a larger, or you could say a wider interval, okay? The reason for that is you're essentially giving yourself more wiggle room, and you're giving yourself more room to be wrong, okay? So take again our an example here. Say you are you've done this experiment and you've written this great paper, and you're presenting it at like a big national conference, a big national meeting, right? You're going to present your data, right? If you want to say that you have a really high confidence that your results are correct, you want to give yourself a wide range to be right. Essentially, you're giving yourself more room to be right. Okay. Your interval can be smaller if you're not as confident, right? But if you want to be really, really confident in your result, you got to give yourself a wide berth, okay, and a wide range, basically, so that you don't look stupid, right? If you're gonna say that you are like 99% confident about something, you got to make sure you have enough space to be right. Okay. So higher confidence means you need a wider interval. Okay. And then in general, a larger sample size means a smaller interval. And when I show you the formulas for how we calculate sample size and how we calculate margin of error and all that fun stuff, you'll kind of see why that is. Okay. All right, so give me just a second to clear my screen off, and then we're going to talk about your word formulas and interpreting your confidence intervals and your confidence levels. All right, y'all. So if you think back to when we did linear regression, right? And I gave you a bunch of word formulas that I told you to memorize when you were asked to interpret something, like interpret the slope in the context of this problem, or interpret the correlation in the context of this problem. Okay, there is a lot of interpreting and a lot of word formulas in inference. So in these confidence intervals, confidence levels, and when we get into hypothesis tests, same thing. Okay, so here are your word formulas for interpreting confidence intervals and interpreting confidence levels. Okay, so here's your word formula. So for a confidence interval, if you were asked to interpret a confidence interval, this is how you would write it. You would say, we are, and then you would list your confidence level. We are this percent confident that the interval from your lower bound to your upper bound captures the true, and then you would say your population value in context. Okay, so the stuff that you see that has the little asterisks next to it, and I'm gonna underline all of that, okay, that's where you fill in information. Okay, so here, 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 and here. Okay, so that's where you're gonna fill in the blanks. Okay, all right, and then for confidence levels, okay, here's your interpretation. Okay, if we take many samples of the same size from the population, Again, this is basically just like rehashing the definition, okay? If we take many samples of the same size from the population, about, okay, again, key there, right? You have your wiggle word, right? So you could say about, approximately, etc. Okay, about, and then confidence level. So this certain percent of those samples will result in an interval that captures the true, and then you again state your population value in context. Okay, so your fill in the blanks are here and here. Okay, and I'm going to do an example for you in a second where I'll actually interpret those and show you what I mean, like how you fill that stuff in. Okay, so an important note before I do that example for you, and this is really important, it shows up a lot on like in multiple choice questions. They'll try to like trick you with this idea. Okay, a lot of people think, and I kind of mentioned this a little bit earlier, that if you are 95% confident in your interval, okay, then a lot of people will think, oh, that means my interval has a 95% chance of capturing the true value. And that's not what a confidence interval and not what your confidence level actually means. Okay, once you've created your interval, that interval either captures the true value, or it doesn't capture the true value, right? What your confidence level is saying is that if we run tons and tons and tons of simulations and create lots and lots and lots of confidence intervals, about 95% of them will capture the truth. Okay. All right. So with all of that, like theory, word formulas, all of that fun stuff in mind, let's take a look at an actual problem. Okay, so give me one moment here because I'm going to rearrange the screen a little bit so that the notes are a little bit larger, because you can see the problem there, and I'll work that out for you. So 1 second, let me pause. I'll see you back here in a moment. Okay, so here's our example. So we have 2 weeks before a presidential election, a polling organization asked a random sample of registered voters this question. If the presidential election were held today, would you vote for candidate A or candidate B? Okay, and then they said, based on the poll, the 95% confidence interval for the population proportion who favor candidate A is 48% to 54%, so 0.48 to 0.54. Okay, so we don't know the actual true value, obviously, of people who would vote for candidate A. Right? It's 2 weeks before the election. Right? We don't actually know that. So we're using our confidence interval as our range of like our best guess. Okay. So the first question here is interpret the confidence interval. So what I'm going to do is I'm actually going to take my, let's see if this is going to cooperate with me. I'm going to take my text up here. Let's see if it'll let me. Oh, no, I don't think it's going to let me copy and paste it. Sad face. I'll have to do it this way. Okay, so I'm going to take my word formula that I already have, and then I'm going to fill in my values here. Okay, so this says we are confidence level percent. So my confidence level is 95. So we are 95% confident that the interval from my lower bound is 0.48, so 0.48, to my upper bound is 0.54. Okay, captures the true, and then we need our population value in context. So the population value that we're looking at is this, the population proportion of people who favor candidate A. Okay, so that's what I have to write. Okay, so it captures the true population proportion, or you could say the true proportion of the population that favors candidate A. Okay, so again, your fill in the blanks were here, 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 and here. Okay. All right. Then part B says interpret the confidence level. Okay, so I'm going to take my already written interpretation. Okay, extend this a little bit. Okay, so if we take many samples of the same size from the population, about, and again, I have my confidence level, so about 95% of those samples will result in an interval that captures the true, and then just repeat what you just said, the true proportion of the population that favors candidate A. Okay. All right. Part C says, what is the point estimate used to create the interval? Okay, so if you recall, right, the point estimate lies in the middle of the confidence interval, right? So your point estimate is like this value, the p hat value, right? And then you have your margin of error. These little knots on the end right here are your bounds, your lower bound and your upper bound, okay? So in any confidence interval, your point estimate is going to be the middle, right? The exact middle of your interval, right? So essentially what you're finding is the midpoint of the interval, okay? Which is, okay, so the way you find a midpoint is you add your two bounds, so 0.48 plus 0.54, and cut that in half. So that's 0.51. Okay. All right. Then the margin of error is just the width of the interval divided by 2, right? So to find that, I have my margin of error is 0.54 minus 0.48, right? Because that's going to give you the length of the whole interval. And then obviously you have to cut it in half because you've got a margin of error on the left and on the right of the point estimate. So I got 0.03. Okay. All right. Now, E is a very common type of free response confidence interval question, okay? And it says, based on the poll, a political reporter claims that the majority of registered voters favor candidate A. And they ask us to use the confidence interval that we have to evaluate the claim, okay? So the nature of a confidence interval is that any value in the confidence interval could be the truth, the true value. Okay, so that's how I'm going to kind of start my explanation here. That any value in the interval 0.48 to 0.54 is a plausible population value. Okay, so in this case, the true value could be like 0.49 of people that favor candidate A, but it could be up to 0.54, right? So it's possible that the majority of registered voters favor candidate A, but it's not certain, right? Because there are values in our confidence interval that don't support that claim, like 0.48, 0.49, 0.5, right, and any number in between those, okay? So that's essentially what you want to write here, okay? So the way that I would phrase this is I would say because the interval contains values less than 50%, so less than 0.5, the interval doesn't provide sufficient evidence to support the reporter's claim. Okay. Now, a note for you here. It doesn't disprove the reporter either. Okay. So essentially, we're just saying there's not enough evidence to support the claim. It doesn't mean that that reporter is incorrect. It just means that I don't have enough statistical evidence to support your claim. Okay. All right. So that's like the basics of confidence intervals. Okay. The last little bit of this video, I want to show you in a little bit more detail what the formula is and what your critical values are and all of that fun stuff, how you determine your margin of error, things like that. Okay, so give me one moment because I need to, again, reset my screen a little bit. And then we're going to talk about how to construct a confidence interval. All right, so here's the last little bit of this video, and it's going to get a little bit more specific about how to construct a confidence interval. In the next one, I'll show you specifically how to do it with proportions. Okay, so as you recall, the general idea of a confidence interval is you have a point estimate and then you have plus or minus a margin of error. Okay, so my general formula for any confidence interval. Okay, so a confidence interval which we use to estimate a population value, a true value, a parameter, is the statistic. So that's like your sample mean, sample proportion, okay, plus or minus your critical value times the standard deviation of the statistic. And I need to add my little plus minus here. Okay, this right here, the critical value times the standard deviation of the statistic, is your margin of error. Okay, now a lot of these phrases, I'm sure, look familiar to you, right? Like statistic and standard deviation. But then the question becomes, what the hell is a critical value? Okay, so here's what a critical value is. Your critical value is just a number, okay? It's a multiplier that makes the interval wide enough to have the stated capture rate. Okay? Those critical values come from the z-table. Okay? So a little bit more specifically, okay, the z-value, right, or the critical value, usually for proportions, it's called like a z-star value, okay? You have to find the z-score that would capture the middle, insert confidence level here, of your data, okay? So as you can kind of see, okay, in this picture, right, of the standard normal curve, if I want to have a 95% confidence level, okay, then I need a multiplier to make my interval wide enough so that I actually can be 95% confident that my interval captures the truth. Okay, so the way that statisticians have determined that we figure that out is we look at the standard normal curve and we say, okay, what's the z value that's associated with the middle 95% of the data? Okay, so if we're trying to capture the middle 95% of the data, that means there's 5% left, okay, in both tails. So that means I'm looking for an area of 0.5 0.025. Okay, so I'm going to go over to my Z table. Here's my Z table. So I'm going to look inside, right, inside my Z table. And actually, I need to zoom in a little bit. Okay, so I'm looking for the area that's as close to 0.025 as possible, right? And I actually have that exact value right here. Okay, so the Z-score that is associated with that area is negative 1.96. Okay, for your critical value, we usually take the positive value, right? The positive and negative doesn't actually matter, right? Because remember, the normal curve is symmetric, right? So you get the same thing on the other side. If you looked at the top 2.5% of your standard normal curve, okay? So this multiplier is going to make my confidence interval wide enough so that I actually can be 95% confident that I've captured the true value, okay? So I'm hoping from here that you can kind of see what I mean, that when you have a higher confidence level, then you need to have a wider range, or you end up with a wider interval, right? So like, for example, let's say I wanted to be 99% confident. Okay, then that means I have 1% left in the tails. Okay, so that means I have 0.5% in each tail. Okay, so here I want to look in my Z table for the number that's as close to 0.5% as possible. So I want 0.005, something as close to 0.005 as I can get. And it looks like I'm right here, stuck between these two, right? So that Z-score, see, that is 2.5. We would say, like, you could choose either 2.57 or 2.58, okay? So larger confidence means I end up with a larger multiplier, a larger critical value, so thus my interval has to be larger, okay? Right? So I'm actually going to go in and like fill all of this stuff in, like on your guys' actual note page here. Okay, so let's jump back to the note page. Okay, so your general margin of error, and I already wrote it up here for you at the top, your margin of error is your critical value times your standard deviation. Okay, and we have lovely formulas for standard deviation. Okay, so a couple of quick things, right, that again we've kind of touched on, but here's your actual reason why this happened. Okay, that your margin of error will decrease when your confidence level decreases. Okay, and I wrote out why for you on your notes. Okay, when you're less confident in something, you don't need to give yourself as much wiggle room. Okay, if you are more confident, you need to give yourself a larger interval so that you really can be sure that you actually are capturing the truth. Okay, so your margin of error will decrease when your confidence level decreases and when your sample size increases. Okay, and when we get to the next video where I show you the formulas for standard deviation, you'll see why. Okay, and a lot of those formulas will look very familiar to you. Okay, because they're very similar to the sampling distribution formulas. Okay, now one thing I want to mention about critical values before I end this video, okay, is no matter what, the critical value associated with a certain confidence level remains the same, like all the time. Okay, no matter what the context of the problem is. Okay, so if you have a 95% confidence, which is the most common type, then your Z star value or your critical value is going to be 1.96. Okay, another really common one is the 99% confidence. Your critical value is going to be 2.57. Right? No matter what the context of the problem is. So the more you do these problems, you'll pick up on a couple of the critical values that show up a lot. And honestly, you'll end up just memorizing them without wanting to, just because you use them so much, okay? But if there's one that you're going to remember, it should be this one, that the critical value for 95% is 1.96, because that shows up more often than any other confidence level in free response questions and in multiple choice questions. All right. So I know this video was a little bit long. Sorry about that. It's kind of a new concept, and this is a really, really big concept. You're guaranteed to find something about inference as one of your free response questions, like every year. Like I guarantee it happens every single year. So we want to make sure we have a really good foundation for what these things are before we actually go in and try to calculate what these things are. Okay. So in the next video, I'm going to give you specific formulas for confidence intervals for proportions, and I'm going to do some examples for you. I'm going to give you a procedure to follow and a lovely acronym. You know me, I love my acronyms, right? That if you use those steps every single time, you will get all of the points and you'll hit all of the things that you need to hit in order to get full marks on the AP test. All right. So with that, I will see you all in the next video. Bye, everybody.